Fundamental concepts. Now, in this particular section, we're going to look at tokenization. What is tokenization? Using tokenization in transformers. We'll also look at model architecture, where we will look at overview of different model architectures like BERT, GPT-2, and others. We'll also look at the difference between all these models. So, to start off with, what is tokenization? Now, tokenization is the process of breaking down text into smaller units called tokens. These tokens can be words, subwords, or characters. Tokenization is a crucial step in preparing text for input into models, as it helps in converting raw text into a format that models can understand. Now, how do we use tokenization in transformers? Now, the transformers library provides various tokenizers corresponding to different model architectures. Let's look at one of the use of tokenizers, which is using the BERT tokenizer. So for this, let's go ahead and start with the project. What I'm going to do is I'm going to save this as tokenizer.py, and inside this I'm going to write some code where I'm going to say from transformers I want to import the BERT tokenizer. Tokenizer, and why always misspell. Next, we will load the pre-trained BERT tokenizer that you can do by creating a variable, and it's called the BERT tokenizer dot from pre-trained BERT base uncased. That's how you get the pre-trained BERT tokenizer. Next, what we're going to do is we're going to create a text. Let's say text equal to Hugging Face is creating amazing tools for NLP dot. Now, to create tokens, I am going to say tokenizer dot tokenize the text. This is the function that we call, and then I can say print tokens. Save it. Let's go ahead and see if it works. And if you see here, so all the tokens are created. Hugging Face is creating amazing tools for NL, and then /pound p dot. So that's how it kind of works because it's capitalized. Next thing that we want to do is convert these tokens into input IDs. So how can we do that in the code itself? I'm going to go and comment this out, not like this. I'm going to say input IDs equal to tokenizer dot convert tokens, that's the function, to IDs. They make it very easy. Tokens, and then I can print this input IDs so you can see how they look like. So run this. This will be an array of numbers. So these array of text have been converted into IDs. So these tokens have converted into IDs because that's what the computers or AI understands pretty much. Next, what we'll do is encode the text for model input. So we can provide it to the encoded underscore input equal to tokenizer. I'm going to pass it the text and get and just set the return tensors to PT. There are a bunch of different other options, but this is what I use. And I can say print encoded input. Let's see how it looks like. Run it, and there you go. That's how the input encoded input looks like, and this is what we can insert into the model. So this is how you can use the tokenizer, the BERT tokenizer, to create create tokens from the input text that is provided. Let's look at the next section, which is the model architecture. Now, to go with the overview of the model architecture, different models are suited for different tasks depending on what you're doing. Here's a brief overview of some popular architectures. First one is the BERT, which is bidirectional encoder representations from transformers. This is designed for understanding the context of a word in search and other tasks. That's what BERT is used for. We have GPT-2, which are very popular and heard quite a lot about, which stands for Generative Pre-trained Transformer 2, optimized for generating human-like text. That's what it's used for, and that's what you use ChatGPT for mostly. Then we have T5, which is text to text transfer transformer, which converts all NLP tasks into a text to text format. That's what it does. We also have RoBERTa, which is robustly optimized BERT pertaining approach, an optimized version of BERT. This is the newer version. They've used BERT as the base, but they've optimized it a little bit more. Now, to look at differences between these models, here is a comparison of some key aspects of these models. On the left side, you'll see all the models that we have listed. The architecture: BERT uses encoder, GPT-2 uses decoder, T5 uses encoder decoder, and RoBERTa, since it's something like BERT, it uses encoder, the same one. Strengths is BERT is used for context understanding, GPT-2 is used for text generation, T5 is used for the versatility, and RoBERTa is used for improved pre-training. Now, the use cases for BERT is text classification, NER, NQA, question answering. For GPT-2, it's text completion, story generation. For T5, it's translation, summarization, question answering. RoBERTa is used similar to BERT, but generally more robust. That's why it's called robust. And we can actually look at an example of using BERT for text classification. So we can go ahead and create another one, and I'll save this as BERTification. That's what I'll call it. And in here, I'm going to create from transformers, I am going to import BERT tokenizer and BERT for sequence classification. I'm going to also use PyTorch for this particular project, since I've already installed this. Now I'm going to create a variable called as tokenizer and use the BERT tokenizer from pre-trained and I'm going to load the pre-trained model, which is the BERT base uncased, which you have probably used in the previous example that you've seen. Next, I'm going to get the model and say BERT for sequence classification and use from pre-trained. In this case, same thing. Copy paste easier. Next, I'm gonna pass some text. I'll use the same text from before, and I am going to create an inputs variable where I'm going to use the tokenizer, pass the text. So I have the encoded data in here, return tensors equal to PD. Okay, so that's what we do. Now, to run the model with this, what I'm going to do is with torch dot no underscore grad is the function that we call, and provide outputs where we'll pass the model and the parameter is star star inputs. That's how I can provide them, because if you see here, this was the model and that's what I'm going to pass it here. And let's print and see how it looks like. If I have not misspelled anything, Let's see, go here, and I'm gonna say the file was called run it. Okay, it has a problem here. No module from transformers. Spelling mistake, as I said. It's always something that I know of. Run it, the usual warning, and it's gonna get my download all the things that I need. So I'll wait for a minute. So if you see, once it's completed downloading, it will go through that process that we said, and it creates this sequence classifier output loss equal to none, logics for tensor equal, this is the array, hidden status none, and attentions is none. So this is perfect. Now next thing that I want to do is interpret these results. So what I'm going to do here is I'm going to say logics that I have there. I'm going to get that outputs dot logics. I'm gonna get that variable, that's the one, right? Logics. Okay, I got that, and then I'll also get predicted class torch underscore argument max and pass to it logics with a dim of 1 dot item. So I'm getting that term back. Let's see what is the predicted class that it put me under. I'm gonna say predicted class. If I want to print it inside, I can just add this predicted class here, and just to make sure that it knows, I'm gonna put F here. Let's run it, and there you go, predicted class is 0. So this kind of gets us to a point where you can probably see how you can use BERT for text classification. Now this particular chapter we have completed fundamental concepts in Hugging Faces transformer library. It converts tokenization, includes how to use tokenizers to prepare text for models, and provides an overview of different model architecture, highlighting their strengths and use cases. And if you have any questions or if you had any issues following along, let me know in comments and I'll get back to you as soon as possible.